Hello everybody, welcome back to PDA, your handheld guide to understanding psychological data analysis. Today we're going to be working with an ANOVA. That's right, we're actually going to hand calculate an ANOVA. As you can see, again, it's just formulas up here, because if I had the numbers, it's way too chaotic. Let's start off with what exactly is an ANOVA. An ANOVA is short for analysis of variance. Okay. And it is defined as a hypothesis test used with one or more nominal independent variables and an interval dependent variable. It's a test for statistical significance of the difference among the means of two or more groups. And it looks at the amount of variability between the means of groups compared with the variability among all the individual scores in the group. When we do this, we use the F statistics. So yeah, that's another different table. And it's got a whole nother curve, which we'll see later on. Before we can start doing an ANOVA and working all these formulas, first we need some data. Someone decided to see if music helps people sleep, and if so, at what volume. So they had 3 people, as they were trying to fall asleep, listen to music playing very softly. 3 people listen to music at a normal volume, and 3 people listen to music at a very loud volume. Here are the minutes that it took for them to fall asleep. We've got 5 minutes, 12 minutes, and 2 minutes for the soft music, which has a total of 19 and a mean of 6.33. There's 20 minutes, 24 minutes, and 17 minutes for the medium music, which has a total of 61 and a mean of 20.33. And the loud people music took 60 minutes, 38 minutes, 41 minutes, and that came up with a total of 139 with a mean of 46.33. Okay, now that we've got all that data, we can start moving on to all of this. First thing we're going to do is get the sum of squares for the total. Now, the formula for the sum of squares for the total is sigma, open parentheses, of x squared, close parentheses. Now, it's very important to have the parentheses on here. Minus, open parentheses, the sigma x, close parentheses, squared, divided by n. So what that means, we need to take every x, 5, 12, 2, 20, 24, all that, square each number, and add it. Brings out this whole slew of numbers, and no, there is no shortcut for it. You just have to do it all. When you get that, you should get... Don't worry if there are big numbers. There's going to be a lot of big numbers. Should get 8,163. Now for this part. This is the total of all the x's squared. So 5 plus 12 plus 2 plus 20 plus 24. Take that total and square it. You're also going to divide it by n. In this case, n is the number of participants. So there's 1, 2, 3, 1, 2, 3, 1, 2, 3. There's 9 people in the study altogether. When you do all this calculation, this should come out to 2,834. Like I said, don't be scared of big numbers. You're not doing anything wrong, but if you get big numbers. For this, the degrees of freedom are just like normal, n minus 1, so the degrees of freedom are 8. Let's try to keep these numbers in mind as we go through the rest of this. This is the sum of squares for the error, or for between groups. You'll see error and between switched off very frequently. Me, I'll stick with error and factor. The sum of squares for the error is sigma of open parentheses, x squared, close parentheses, which, hey, we found out up here. Alright, one less thing we have to do. Minus the sigma of the collective total squared divided by the number of collective total. Huh? Okay. All that means is collective total is, say for the soft music people, the collective total of that, 19. That's what everything adds up to. So you square that, and you divide it by the number of cases in that column. So it'd be 19 squared divided by 3. And you do that for each of the cases, or for each different variable. So you do it for the soft column, you do it for the medium column, you do it for the loud column. Once you do that, you should come up with 362.01 for your sum of squares for the error. The sum of squares for the factor should be sigma of collective total squared divided by n of collective total. Hey, we did that too! Alright! Minus sigma, open parentheses, sigma of x, close parentheses, squared divided by n. Well, we have that up here too. You know what? Maybe this isn't as much math as we thought. So all you do is bring this number down from here, bring this number down from here, work it through. You work it through, and you should get 2,471.99 as your SS of F. Now, we're going to go ahead and check this, because our SS total should equal the SS of E plus the SS of F. So, sure enough, if you add 362.01, which is what we found here, plus 2,471.99, you come up with 2,834, which is what we found for the SS of T. Alright, we're doing good so far. Next comes the degrees of freedom. Well, wait, I thought we already had the degrees of freedom. Well, that's right, we do. We said it was 8. But now we're double checking to make sure that it actually is 8. The degrees of freedom total equals the degrees of freedom for the error and the degrees of freedom for the factor. The degrees of freedom for the error is n minus k. And n is going to be 9, because that's how many you have, how many scores you have. And k is the number of groups, which is going to be 3, because there's only 3 groups. You can only be in soft, medium, or loud. So you do that, you find out the degrees of freedom for the error are 9 minus 3, so that's 6. And the degrees of freedom for the factor, here's that k again. So we know there's 3 groups, and it's 3 minus 1, which is 2. 6 plus 2 is 8. Alright, our math is doing good. Lastly, we've got the mean squares here. Mean squares are not that mean. They're actually nice. All you do, for the mean square of the factor, you take the sum of squares for the factor, which we found out up here, divided by the degrees of freedom for the factor, which we found out over here. Once you do that, you should come up with 1,236. We're going to do the same thing for the mean squares of the error, which is the sum of squares for the error divided by the degrees of freedom for the error. When you come up with that, you should get 60.34. Now that we have ms of f, of the factor, and ms of e, we can find out the f statistics, which is what we need for our ANOVA chart. The f statistic is ms of f divided by ms of e. When you do that, you should get 1,296.34. This is your f statistic. And f statistics are written as f and then 2 degrees of freedom, because we have 2 separate degrees of freedom, equals your statistic. So for example, we would have f, open parentheses, 2, because we found there were 2 degrees of freedom here, comma, 6, because there were 6 degrees of freedom here, close parentheses, equals 1,296.34. The general rule of thumb when writing an F statistic is to have the degrees of freedom in rank order. So you put the lowest degree of freedom first, and then the highest. Okay, so we've got all these numbers. but that's still a little messy. So what we're going to do is we're going to take away these formulas and we're going to put up something called an ANOVA table, which has all the information we just found in a nice, orderly presentation. And here we have a completed ANOVA table. The columns for this are source, SS, DF, and MS, which we just found. The source is factor, or between, and error, or within. So SS of F, of the factor, is 2,471.99. That gets put here. The SS of E is put here. Degrees of freedom of F, degrees of freedom of E, the MS of F, and the MS of E. See, isn't this a lot cleaner than all the stuff? I mean, I've got like a full page of just writing out all this math. Whereas this, very easy to understand. And it looks great in a report, too. Here's how you would write the F statistics. As was mentioned, you put the lowest degree of freedom first, followed by the highest, or you rank order them depending on how many degrees, and then you put what it equals. Okay, so we've got this, and you know what that means. Whenever we have a letter statistic, we need to go back to a table and back to a curve. So let me draw that up for you. Alright, here's our ANOVA curve. As you can tell, it's slightly misshapen, but that's the way ANOVAs are. This is a one-way ANOVA, so we're only looking at one tail. If you go to your book, you'll find a table similar to your T and Z distributions. However, it's the F distribution. Actually, no, it might not be too similar. This looks a bit confusing. Well, let me deconfuse it for you. You remember how I said factor and error can be switched out with within and between groups, respectively? Okay, well, sorry to confuse you. After further review, I have found out that error gets switched around with within, and factor is switched around with between. See, this is why I like to stick with factor and error, but oh well. So, remember, factor and between groups are the same thing, and error and within groups are the same thing. Think, ew, like this whole thing is messy. That will give you E and W. So if you look in your book now, we can find the within groups degrees of freedom was 6, and the between groups degrees of freedom is 2. Pull that down, and in order to be significant at the 0.05 level, we need to have an F statistic of 5.14 or greater. I don't know about you, but I'm pretty sure that 1,296.34 is much, much, much greater than 5.14. If this is 5.14, we're probably like over here somewhere off of the board here. So in that case, this is very, very significant, and the level of music does have an effect on how long it takes you to fall asleep. Now, ANOVAs are a very confusing thing, as can be seen. That's why SPSS will also do your ANOVAs for you. I hope this has helped you to understand ANOVAs a little better. I know it's helped me working through one. So if you have any more questions or you'd like to know a little bit more about ANOVAs, have a look at the link at the end. Have a good day.